Yes, so I'm Douwe Faasen. I'm the founder of Hyve. And I'll be talking to you today about from block space to data economies. So the goal of today is to tell you a bit more about what Hyve is and specifically about why we built it. So the reason that we built Hyve is because of the things that we saw that decentralization did to projects on top of Ethereum. And specifically what we also saw was lacking currently in a lot of these data-heavy protocols. So with Ethereum and DeFi and rollups, you really saw that block space was not just some kind of like technical plumbing or some kind of technical tool, but it was something that you can secure and price, but mostly also very importantly build stuff on top on. So specifically with DeFi, what you saw with DeFi is that the use case of blockchain is incredibly clear. You have smart contracts that govern the rules of an economy, and then you have all of these DeFi protocols that move value around. And then specifically all of these DeFi products you can build on top of other DeFi products. So in Avi, you have the positions that compose with other protocols, and you have Uniswap liquidity that does not only serve as Uniswap itself, but also can form collateral in other protocols. Everything is composable, and because everything is composable in such a trustless manner, it becomes an entire economy where you don't have these isolated applications, but you actually have this entire thriving economy where everything composes into each other. And when you look at the current data-heavy side of Web3, so talk about like order books on Polymarket, or talk about data in DePIN networks such as Grass or Helium, or talk about documents of RWA projects. All of this raw data is currently sitting mostly in clouds. So it's hidden behind APIs, it's sitting in proprietary systems, and it's essentially hidden away for trustless composability. And this is a big limiting factor for these kind of data-heavy protocols to actually transform from these Web2 style markets that are mostly dependent on APIs into these decentralized data economies where everything can compose on top of each other. And that is the fundamental gap that Hyve tries to address. So we want to bring the composability to these kind of data economies. And well, yeah, make them data economies actually, because right now they're just data markets. And you're also not talking about like kilobytes of data, but you're talking really about petabytes of data every single day. A good example to really like make it practical about these data economies is take, for example, Hyperliquid. So you can see the amount of applications that are on Hyperliquid doesn't even fit in the entire slide. And it is because Hyperliquid built an L1. So it made all of the critical data, which in this case is the order book, it made it completely composable and transparent, and anyone can use the order book to build on top of, to use it. And this all happens through smart contracts. With smart contracts, you can directly edit the order books on Hyperliquid. And what this resulted in is a ton of different products, applications, analytical tools, quantitative tools, all being built on top of Hyperliquid. And that transformed it from a single entity market into an entire economy for just trading. And even though there were tons of different perp dexes that were also trying to build a decentralized trading experience, such as Binance DEX or DYDX, they never got this kind of product market fit that Hyperliquid did, because Hyperliquid really nailed the composability of it. And it really incentivized people to build on top of and really get that key use case of decentralization, which is to build entire economies. And now, what does that mean for like a DePIN project or an RWA project or an AI project or other order books? Do they also just need to build an L1? Or because they're dealing with more of the raw data, such as documents or raw IoT or device data, do they maybe just need to store their raw data somewhere? Would it be enough for these kind of protocols to just switch from AWS to, for example, Filecoin? If you look at from the perspective of like the project itself, all it would be doing is switching vendors. It would be just switching from paying AWS to paying Filecoin. But it wouldn't really retain that value in its own protocol. So this whole goal of making an economy out of your data would be basically entirely lost. And that's what Hyve did different. So what we've built is what we call a hot data fabric. So first of all, we have the performance. So we built a very performant layer that can handle gigabytes per second in throughput, completely low latency writes, low latency reads. And on top of that, we didn't build a layer 1 or an L2, but we built this unique architecture that is a horizontal layer that anchors to chains. So that means that we have more things to play around with when we want to introduce sovereignty. And sovereignty is something very important, because then you are not just switching vendors from AWS to Filecoin. So that's what Hyve introduced. What Hyve introduced is data clusters. And data clusters are essentially these things where any kind of project, whether it's a DePIN project or an RWA project, can create a data cluster within Hyve, make a completely composable data environment with its own participants, such as stakers, operators, its own governance, but also its own token. This token will be used both for the fee asset, but also for the security budget asset. And what that does is that when a DePIN cluster, for example, exists and it launches such a cluster, then the value that it gets from creating all of this data retains within its own token economy. So no longer will that DePIN project be using an external kind of infrastructure where it would be either participating in the tokenomics of that infrastructure project or even become like a secondary project to that infrastructure project. It will completely embed the data into its own ecosystem and thereby retain the value that gets created from all of these participants creating data. And what that looked like in more practical terms is consider any kind of data-heavy project, whether it's an RWA, whether it's a DePIN project or an AI project or an order book. You have different participants. You have data producers, such as document issuers or users or applications, and you have data consumers. So those are other applications, those are analytical tools, those are other protocols built on top of it. And then, of course, you have the participants that are actually maintaining the protocol. So you have the stakers, the operators, and the token holders. Normally, what would happen is as the data and the consumers and the producers, they would make their fees and the rewards flow towards the stakers of this one global layer. But with Hyve, because we didn't build one single global layer, but we built these sovereign clusters, now the rewards flow towards the operators and the stakers that are directly embedded within their protocol. So now instead of having to define your own L1 or having to rely on this AWS, you can just embed Hyve and have a completely composable data set that is also high performance, but also profit from that composability in turning it into a true economy. And okay, weird slide. Anyway, so the reason that this is also possible is because Hyve, again, did not build an L1. So we are this horizontal data layer, and it means that we just focus on the data itself. We don't have our own L1 where people need to extract their tokens towards. We don't have like a risk when it comes to the security. We just focus on the data. And the only risks that we focus on is the coordination of all of this data being available, having integrity, and being of high performance. But all of the staking and all of those participants that I was just talking about, they are sitting on the settlement chain. So we can attach to multiple settlement chains. Right now, we start with Ethereum, and we do this with Symbiotic. And the way that we do that is we have the Symbiotic smart contracts, and then we can spin up another cluster inside of Ethereum that all the operators will register on, that all of the stakers will go towards. And that is where all of the security or the crypto economic security is also maintained. That means that there's no risk when it comes to, for example, depositing your value inside of like a Hyve chain. But instead, people can already use battle-tested infrastructure and depend on that. And most of the tokens of people that want to launch their own cluster are also sitting in such a settlement chain. Whether that's Ethereum or some other kind of chain, Hyve will be able to support that. So that means that the risk is dramatically less, as well as that we have no attention on like reinventing staking or having to put any kind of bridging or putting data economies to like a preferred kind of layer. And where we are with Hyve right now, we've built a DevNet where we are able to basically ingest up to 5 gigabytes per second, but it is horizontally scalable. So the more clusters there are and the more nodes that participate in the network, the more throughput that we can actually handle. The latency is also incredibly low. So that means for a large DePIN project or an RWA project, you now have the performance that you already got with the cloud solutions that you're using, but now you also have your data sitting in this open layer where other people can build on top of it, and you can really transform your project from like this isolated market into a data economy. And yeah, other than that, I would say thank you. And if there's any questions, please let me know.
Thank you very much for your presentation. I'm curious, what would composability look like with this data?
Yeah, good question. Take, for example, an RWA project, for example. What you have right now is that all of these documents that power the on-chain assets are sitting in a cloud solution. So that means that it's hidden behind an API, and the only way that you can kind of audit this is well, depends on all of these oracles doing a proof of audit, but you can't verify that, and decentralization is also mostly powered by the ability to self-verify something. So if you want to build, let's say, a lending platform on top of an RWA, or build some other kind of RWA on top of an RWA, you can't really do that in a trustless manner. So you don't have the same thing that Hyperliquid has, where you have a self-verifiable access to the order book and you can edit the order book. You don't have this with RWAs, where the documents that power the on-chain asset are sitting in some kind of proprietary system that's inaccessible in the chain economy. So when you put that into Hyve, then it becomes open, accessible, and self-verifiable. You can still run audits on it and outsource that, but you can now self-verify those audits. So that will power DeFi use cases of RWAs, that will power other RWAs to be built on top of RWAs, and make everything composable in that sense.
Nice, thank you. I have another question. On one of your slides, you showed that Symbiotic has operators, and then below that, there was some kind of flows, and then you had Hyve. I assume in Hyve, you have your own operators, and if so, how many operators are you looking to have, maybe early and then later, and what kind of hardware and bandwidth requirements, and maybe like data, because they have to store data maybe temporarily or permanently. What does that look like?
Yeah, good question as well, and I think this is the slide probably that you were referring to. So in terms of the amount of operators that we have, like the set of operators is completely permissionless, so anyone can join. And right now we have like kind of these well, benchmark or these targets of operators, which scales from 64 operators all the way to 256, where it's most likely that in the beginning we'll have 64 and then it will scale up to 128. And from like 256, the performance starts to degrade. So that is completely permissionless. We have like partnerships with several like institutional operators. But once we hit mainnet, that's when we also want like a smart contract where anyone can essentially join as an operator. And then through symbiotic relay, that's how the entire on-chain state also comes into like our off-chain operators or our data nodes. And when it comes to like the requirements for the operators, it's pretty low. It is like 16 gigabytes of RAM should get you there. Then about like 12 CPU cores. And yeah, for the bandwidth, we recommend like 100 megabits per second. But it can be even less as well. It really depends also on the performance targets of the cluster. So if you want like a bit of a more, vertically scaled cluster, but with less nodes, then you might increase the performance requirements. And we're also working on like a way to actually audit the performance and make that slashable as well. But that's probably a couple of months, maybe a year away as well.
I have one more question, actually. So if I'm, for instance, we can take the RWA cluster. So if I'm an issuer, I join the cluster, and then I have access to the data on all the RWAs in that cluster.
Yeah, it would work like that. If you have like a shared cluster between RWAs, you could also choose to make your own cluster for just your RWA project.
Okay. And then one follow-up question. What is the fee structure like? So I can see here that if I'm a participant, right, I have to store the data, I have to pay. If there is data from the cluster that is sort of not mine, that I'm not storing, that someone else's, to have to pay to like extract that data, or how does that work?
Yeah, we will have, basically for the fees, it will be, you have to pay a fee to publish your data. And you can pay a fee that depends on the cluster as well. You can pay a fee to extract the data. There might be some cases where, for example, there's free egress, but I expect in the beginning there will be incentivized reads. But then to confirm that your data is there, that will be free. But then you won't be able to reconstruct your data.
And are the fees sort of determined based on the size of the data and all of that, or is it like a subscription?
Yeah, it's depending on the size of data and how long you want to store it. So it's very much like the cloud model where you pay in like gigabytes per month.
Thank you.
No worries. Perfect. Thanks.